conditional probability. So when we work out the probability of an event happening, but knowing some conditions, something that's already happened. And here's our formula. The probability of A, given that B's already happened, equals the intersection of the two, probability of A and B, but dividing it by the probability of B happening. Of course, the other way we could say it over here is you could simply look at the number of possibilities. So look at how many are in the different spaces. So number in intersection B over the number in B. But here's the thing. If it turns out the probability of A, given that B's already happened, is actually the same as the probability of A, then A and B must be independent events. Because the fact that B had already happened did not change the outcome. So they must have been independent of each other. Mixed language class. So students study French, Latin and Japanese. Ooh, much like here. The number of students who study each language is shown in this particular Venn diagram. What is the probability that a student who studies Japanese also studies French? We look at our Venn diagram. As far as we're concerned, our universal set is now Japanese. Studies French, we have a look in that set and there's only 3 of them. So it's 3 out of 10. That's how we could use our Venn diagram for doing it, rather than the formula. I mean, the formula would work as well, but essentially I've used the second part of the formula where I've just simply counted how many there were, rather than working out the probabilities. 2 boxes each contain 4 stones. The only difference is the colour of the stones. Box 1 only has black stones in it, whereas box 2 has got 2 black stones and 2 white stones. First of all, we choose a box at random. Then we'll draw a stone from that box at random. What's the probability that the stone that I end up getting is black? Well, I'm going to have to consider 2 possibilities here, because first of all, which box did it come from? I've got a 1 in 2 chance of picking box 1. But of course, if I pick box 1, I must get a black stone. So there's a 1 in 2 chance if that happened. But the other possibility there is I pick box 2. Well, there's a 1 in 2 chance that I pick box 2. But in that box, I've got a 2 in 4 chance of picking a black one. Add the 2 possibilities together, we get 3/4. Of course, the other way I could do it is probability of black. Well, there's 6 stones that are black overall. And because the probability of picking the boxes were equally likely, it actually really doesn't matter whether the boxes are separate or the boxes are together. It's still the same as if it had been one big box and I pull out a stone and we get 6 out of 8, 3/4. But if it's not known from which box the stone has been drawn, so I don't know which box it comes from, given that the stone drawn is black, what was the probability that it came from box 1? So it's sort of a little twist on the question there. So we don't know which box it came from, but we know we ended up with a black one. So which box did it come from? What's the probability that it was box 1? Now I'll use conditional probability. I say, well, what's the probability that it came from box 1 if I know it was a black stone? So probability of black and box 1 over the probability of black overall. So I get a half times 1, and then over the 3/4, a 2 in 3 chance. A bit of logic kind of tells you that as well, because if you look at the ratio there, there's 2 black stones in that one, 4 in that one, it's double the other one. So yeah, okay, 2 in 3 chance. In this particular school, 55% of the students are male, 45% female. Of the male students, 13% say Monday is their favourite day, while 18% of the females say Monday is their favourite day. Sure, it's everyone's favourite day. We're back at school, yay. Find the probability that a student chosen at random is a male whose favourite day is Monday. Probability of the person being male, they said 55%, so 0.55. Probability that Monday is their favourite day, given that they were male. Well, that's 13%. Okay. Here's our formula. Probability of Monday given that they're male will equal the intersection over probability of male. Sub in the info we got, let's rearrange it. Okay, probability of being a Monday and a male, which is what we're trying to find. Student chosen was both male and their favourite day was Monday. We can work that out now to be, well, 0.0715. Very small probability. Let's look at an actual HSC one. So it comes from a couple of years ago now. In a bag, there are 3 6-sided dice. Now these dice are not normal dice. We can see the first one's marked 1, 2, 3, 4, 5, 6. Well, that's what we expect. But the other one, 1, 2, 3, 5, 5, 5. One die is randomly selected and tossed. Probability, we end up with a 5. Okay. Well, probability is a 5. We have 2 in 3 times 1 in 6 plus 1 in 3 times 1 on 2. Where did that come from? There are 3 6-sided dice. Well, there's a 2 in 3 chance of getting one of the ones that it's regular, 1 to 6. So there's your 2 in 3. And on that die, there's a 1 in 6 chance of getting the 5. Or I might have got the other dice. Well, there's a 1 in 3 chance of getting that special one. And on that one, there's a 1 in 2 chance, or a 3 in 6 if you prefer, chance of rolling the 5. Put it all together, 5 in 18. But given that the die does show a 5, what's the probability that it was the special die? Okay, we go to our conditional probability formula. Special die, given that it was a 5, probability of both things happening over the probability of 5 itself. Just subbing in those different bits, we end up with a 3 in 5 chance. 3 in 5 chance. Of course, I could have done it with the use of a Venn diagram. As far as die 1's concerned, remember, it's given that it shows a 5. So as far as we're concerned, in die 1, there's just one outcome there, a 5. Die 2, one outcome, there's a 5. Special die, we have 3 5s. There is our Venn diagram now. So probability special die, well, 3 out of 5. There are 5 5s there all up, but 3 come from the set that is the special die. So we could use Venn diagrams to solve that problem. We'll add 12G to our list.